Okay, so here we have a permutation question. You might remember that the formula for permutation is the following. You have NPR equals n factorial over n minus r factorial. What does all of this mean? Well, n represents the amount of stuff you have, right? And r represents the stuff you're going to choose. N factorial, right, for example, could mean if it was 9 factorial, it would mean 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And here, right, so you're multiplying from n all the way down to 1. We subtract r from n and then take the factorial of that. Now I'm going to use a permutation, right, P for permutation, because in this question, the order, right, does not matter. Excuse me, does matter, what am I saying? Right, so every time I rearrange my letters in a different way, this matters. It's a new word. So here's what they're asking. They're saying how many different three-letter arrangements can be formed using the letters in the word absolute if each letter is used only once. So, okay, so how many letters are there? Well, there's A, 1, 2, 3, 4, 5, 6, 7, 8. So we can plug that right into our formula here. Right, we have 8 things, 8p, and we're choosing 3 of them. So we solve this. What's 8 factorial over what? Well, n minus r, so 8 minus 3 factorial. If we simplify this, we get 8 factorial over 5 factorial. And this is actually easy to solve because 8 factorial means 8 times 7 times 6, all the way down, right, to 1 times 2 times 1, and 5 factorial means 5 times 4 times 3 times 2 times 1. What's nice is 5 factorial will cancel out all of this right here, right? The 5s, 4s, 3s, 2s, and 1s all divide down to 1. So here the answer is just 8 times 7 times 6, right? And of course they don't give you that answer in that form, so you have to multiply this out. So what's 8 times 7? I know again you have a calculator so you can do this faster. That's 56. What's 56 times 6? Well, 6 times 5 is 300. 6 times 6 is 36. That's 336. And that's choice 4. Now I know I didn't talk about any reasons about why this works. It's just that I want to show how to apply this formula. Please go back and check videos on these concepts if you're feeling confused about what just happened. Also be aware that there's another type of question about this. We're looking at combinations, and that's a little different from permutations, right? In permutations, every time you change the order of the letters, it would matter. A combination would say the order doesn't matter. So for example, if I picked A and B and S, or if I wrote that as S and B and A, right, or B and A and S, doesn't really matter. With combinations, you're saying all of these are the same because they used the same 3 letters. However, permutations looks at this and says, oh, these 3 are different because the order does matter. So permutations, P, is when you are dealing with order and the order does matter. Combinations, which I'm sure we'll look at in other videos, are when the order doesn't make a difference. You don't have to count these as different ones. All right. Hope that helps.